In lesson 14.6, you will apply the sum and difference formulas. In our first example, we want to find the exact value of the tangent of 15 degrees. Now 15 degrees isn't a special angle, so we want to rewrite that 15 degrees in terms of special angles, and I'm going to write it as 60 degrees take away 45 degrees. So I have the tangent of a difference, and I can use the difference formula for tangent in order to evaluate. I can write this as the tangent of 60 degrees minus the tangent of 45 degrees over 1 plus the tangent of 60 degrees times the tangent of 45 degrees. And now I'm going to want values for those functions, so I'm going to look at the triangles, the special triangles. I'll look at a 30, 60, 90 degree triangle whose sides are in the ratio 1 to the square root of 3. And I'll look at a 45, 45, 90 degree triangle whose sides are in the ratio 1, 1, the square root of 2. Okay, so now the tangent of 60 degrees is opposite over adjacent, or square root of 3 over 1, which is just the square root of 3. The tangent of 45 degrees is opposite over adjacent, 1 over 1, or just 1. In the denominator, I have 1 plus the tangent of 60 degrees, which was the square root of 3, times the tangent of 45 degrees, which was 1. So just simplifying, I've got the square root of 3 minus 1 over 1 plus the square root of 3. Now the only thing left to do with my answer is to rationalize the denominator. So I want to use the conjugate of that denominator, 1 minus the square root of 3 over itself, that form of 1, and multiply it to this fraction to get rid of the radical in the denominator. So I'm going to have to distribute top and bottom. And the square root of 3 times 1 is square root of 3. Square root of 3 times negative square root of 3 is minus 3. Negative 1 times 1 is negative 1. And negative 1 times negative square root of 3 is positive square root of 3. Now in the denominator I have the sum and difference of the same two terms, so the middle term is going to cancel out. It's going to sum to 0 when I distribute, so I'll have a binomial. 1 times 1 will give me 1, and the square root of 3 times negative square root of 3 is negative 3. And now adding like terms in the numerator, I'm going to get negative 4 plus 2 square roots of 3. And in the denominator I have negative 2, so I'll divide both terms in the numerator by that denominator of negative 2 so that I can simplify to 2 minus the square root of 3. Now this is my final answer. This is the exact value of the tangent of 15 degrees. Okay, in example 2 here we want to find the exact value of the cosine of 7 pi over 12. 12ths doesn't give us a special angle, so I'm going to rewrite that cosine again in terms of special angles. So I will write it as 3 pi over 12 plus 4 pi over 12, because that sum is 7 pi over 12. And I'll simplify those angles, because 3 pi over 12 simplifies to pi over 4, and 4 pi over 12 simplifies to pi over 3. Now these are special angles, so I will use now the sum formula for cosine and write this as the cosine of pi over 4 times the cosine of pi over 3 minus the sine of pi over 4 times the sine of pi over 3. Okay, and now substituting in values for those functions. The cosine of pi over 4 is a 45 degree angle, so if I go up above and apply the definition of cosine, adjacent over hypotenuse, I get 1 over the square root of 2. And pi over 3 is a 60 degree angle, so I'll go up above and apply the definition of cosine again, adjacent over hypotenuse, and get 1/2. Then sine of a 45 degree angle opposite over hypotenuse is going to give me 1 over the square root of 2. And the sine of pi over 3, or 60 degrees, opposite over hypotenuse, is the square root of 3 over 2. So now when I multiply and get my products, I'm going to have 1 over 2 square roots of 2 minus the square root of 3 over 2 square roots of 2. I have a common denominator, so I can subtract those numerators and put them over my common denominator of 2 square roots of 2. Now the only thing left to do with this answer again is to rationalize that denominator. And if I multiply by the square root of 2 over itself, that form of 1, I'll be able to get rid of the radical in the denominator. So I'll distribute in the numerator. Square root of 2 times 1 is the square root of 2. And the square root of 2 times negative square root of 3 is negative square root of 6. Over square root of 2 times itself, which is 2, and 2 times 2 is 4. Now that's my final answer. That's the exact value of the cosine of 7 pi over 12. Okay, in this example we want to find the cosine of a difference. Given that the sine of A is equal to 1/5 and A is between 0 and pi over 2, and the sine of B is equal to negative 5/13 and B is between pi and 3/2 pi. So first I'm going to locate this angle A on the coordinate plane. Its terminal side is between 0 and pi over 2, so its terminal side is in the first quadrant. I'll apply the definition of sine, opposite over hypotenuse. So I want to complete this triangle by using the Pythagorean theorem, and that hypotenuse squared is equal to the sum of the legs squared. 1 squared is 1. So x, that missing side in that right triangle, is going to equal the square root of 25 take away 1, or 24. And that simplifies. The perfect square factor in 24 is 4. Square root of 4 is 2, so I can write it as 2 square roots of 6. Okay, and now locate B on the coordinate plane. Its terminal side is between pi and 3/2 pi, so its terminal side is in the third quadrant. This is our angle B. Applying the definition of sine to this triangle, opposite over hypotenuse, I have negative 5 and 13. So now I need to find a missing leg again. 13 squared is 169. That's equal to negative 5 squared, which is 25, plus x squared. And x then is going to equal the square root of 169 take away 25, which is 144, or 12. And it's going to be negative 12 in the third quadrant. Okay, now I can go back and find the cosine of that difference, A minus B. I can use my difference formula for cosine and write that as the cosine of A, cosine of B, plus the sine of A, the sine of B. And now substitute in values for cosine of A, which is adjacent over hypotenuse, or 2 square roots of 6 over 5, times the cosine of B, which is adjacent over hypotenuse, or negative 12 over 13, plus the sine of A, which was given as 1/5, times the sine of B, which was also given as negative 5/13. And simplifying, getting these products, I have 2 square roots of 6 times negative 12, that's negative 24 square roots of 6, over 5 times 13, which is 65, minus, positive times a negative is a negative, 1 times 5 in the top, and 5 times 13 in the bottom again is 65. So I have a common denominator, so I can add those numerators and put them over that common denominator of 65. Now there's no radical in the denominator, so this is my final answer. This is the exact value of the cosine of A minus B. Okay, here we have two more examples. In the first one we want to simplify the expression, the sine of a sum. So we'll use our sum formula for sine, and we'll write that as the sine of x, cosine of pi over 2. plus the cosine of x, the sine of pi over 2. Okay, and now the pi over 2, if I graph that 90-degree pi over 2 radian angle, I'm going to have this ratio 1, 1, 0. And applying the definition of cosine first, cosine is adjacent over hypotenuse, 0 over 1, so that's going to have a value of 0. And now applying the definition of sine to pi over 2, I've got opposite over hypotenuse, 1 over 1, or 1. So 0 times sine x is 0, 1 times cosine x is cosine x, so the whole thing simplifies to cosine x. Okay, in the second example on this page, we're solving an equation, and we've got the cosine of a sum in our equation. We want solutions for x between 0 and 2 pi. So the first thing I'm going to do is use my sum formula for cosine and replace that cosine of a sum with cosine x, cosine pi over 2, minus sine x, sine of pi over 2, and that equals -1. Okay, now I need values for the cosine of pi over 2 and the sine of pi over 2 again. So substituting in for the cosine of pi over 2, which is adjacent over hypotenuse, 0 over 1, I'm substituting in 0. And substituting in for the sine of pi over 2, which was opposite over hypotenuse, 1 over 1, or 1. Inside parentheses, since 0 times cosine x is 0, I'm going to be left with 1 times negative sine x, which is just negative sine x. And so getting sine x alone, I'm going to first divide both sides by 2 to get negative sine x equal to -1/2, and now I'll either have to divide both sides by -1 or multiply both sides by -1 to get sine x equal to +1/2. And now I'll go to the coordinate plane to find out where the cosine is positive, and that's going to be in the first quadrant and the second quadrant. So applying the definition of sine to this first triangle, opposite over hypotenuse, 1 over 2, I'll recognize the special triangle 1, 2, the square root of 3, and know that the reference angle that I'm using is a 30-degree angle, or pi over 6 radians. So now I can solve for x and name that first terminal side in the first quadrant pi over 6 radians, or that terminal side in the second quadrant. Since my reference angle is pi over 6, I would go 6, 6 and back up a 6. So to name that terminal side, it's 5, 6 pi in the second quadrant. So those are my solutions for x in this equation. Include with your notes of this video guided practice problems 1 through 7 odd on pages 950 and 951 of your textbook.